Okay, since we are done with the collection and organization of the data, now we'll have the presentation and the interpretation of our data. Okay, so today we delve into the art of the data presentation. Let's try to unlock the power of statistics and learn how to present them effectively. Okay, so as you can see here on our slides, we have three types of data presentation. We have the textual, tabular, and graphical. Okay, so let's talk about choosing the right visuals. Okay, so it's not just about the numbers, but with a context. It's our job to transform those numbers into compelling stories that drive decisions. Okay, so it's important for us to analyze the data that we have collected. So to present those data, we have the textual, we have the tabular, and the graphical. So starting with the textual presentation is the most straightforward. It involves presenting the data in written or numerical form. Often it is in paragraph form or bullet points. Okay, in textual data, it can provide detailed descriptions, explanations, and a context. It's usually used in reports, articles, and even with the academic papers. While the tabular presentation, it's a presentation that organizes data into rows and columns. So we have here a table. It resembles a spreadsheet like in Excel or Google Sheets. It's a structured format that allows for easy comparison and reference. Usually we have the table, frequency distribution table, that is used when it comes to both quantitative and qualitative purposes. Tables are ideal for presenting precise numerical values and relationships. They are commonly used in financial reports, scientific data, and database. While here in graphical presentation uses a visual elements like charts and graphs to represent the data. Okay, so later we're going to discuss different types of charts or graphs that is commonly used. Okay, it's a power tool for making complex information to easily understand at a glance. Okay, so graphs are usually excellent for showing the trends like the line graph, comparisons like the bar graph, distribution also. Uh, Also when it comes to allocation of the percentage such as the pie chart. Okay, so now let's try to discuss each. Okay, let's try to discuss each types of or kinds of charts or graphs. Starting with the bar graph. A bar graph is a graph drawn using rectangular bars to show how large each value is. The bars can either be horizontal or vertical. So as you can see here, on our example, unique individual tested per day, it used vertical bars. While here, also, it used vertical bars for the another example. So I forgot to present an example that used horizontal bar, but it can be either. It could be horizontal or vertical. And also, when it comes to the bar graphs, each category has its own bar. If you look at this, we have x-axis for its categories and y-axis for the frequency or the count. Okay, so usually bar graphs are for comparison among distinct categories. So as you can see here, we have each day, the number of unique individuals that is tested daily during the pandemic. Okay, this is during the pandemic from April up until May. And then another example here, we have the difference between the savings of Popol and Kupa from Monday to Friday. Okay, so as you can see the difference uh, with their savings. Okay, so as you can see, that is for the bar graph. Okay, it's a comparison among the distinct categories. Okay, so now, how about the pie chart or the pie graph? Here, when it comes to the pie chart or the pie graph, we have a circle that is divided into sectors proportional to the frequencies. Okay, so as you notice here, in our example, we have the distribution of the expenses and the profit of a certain company. Okay, we have here elements for the office rental. We have for the taxes, wages, maintenance, operating expenses, even the profit, of course, and others. Okay, so as you can see, you can identify, you can see the percentage of that to the total. Okay, so it's important to define what the whole represents, of course. It is used when you are showing the relative proportion or percentage of numbers that add up to a sum. So when it comes to this, take note, you can use this when it comes to presentation of the demographic profile of your respondents, such as you compare with the number of male and female in your study, their socioeconomic status, even when it comes to the distribution of the year level. If you're going to focus on the respondents here on our university, the year level, the freshman, sophomore, junior, and senior, you can identify the percentage using this pie chart or pie graph. Another one, we have the line graph. Okay, when it comes to the line graph, it shows trend in data clearly. It's a graph that shows information that is connected in some way. It is used when you would like to show how one value changes with respect to another over a certain period of time. For instance, we have here the population or the number of cases of positive cases during the COVID-19 pandemic. So as you can see, we can see the trend, the increased number of positive cases here in the Philippines from the February up until April 2021. Okay, so as you can see, we can also identify the possible number of cases of COVID-19 from March up until the August. You can identify the peak. Okay, so as you notice, the prediction of the UP and Ayala Analytics Group, the peak of or the highest, possible highest number of positive COVID-19 during that time is during May. Okay, so line graph, you can also have an example for the population. The population of our country every decade or every year. We can identify that it's still increasing or is it decreasing and so on. Okay, so again, when it comes to the line graph, take note. Okay, take note, it is all about the trend. It's about the trend. Also, when it comes to business, you can identify it when it comes to the stocks. Okay, you can identify its prices. Is it increasing or decreasing every day? You can identify. You can identify. It's similar to bar graph. It has horizontal and vertical axis where the scale which is equal interval. Next one, we have the histogram. Histogram is like a bar graph, but we should identify its difference. Okay, by the definition, histogram is a graphical representation showing a visual impression of the distribution of data. It is a bar graph showing data in group frequency table. The bars are placed next to each other to show that as one data interval ends, the next data interval begins. So as you can see here by its definition, in bar graph, there are spaces for the bars, while here, histogram is continuous. Okay, it is continuous. So when it comes to bar graph, usually it's for categorical data, while histograms is for continuous data. Bar graphs, each category has its own bar, while histogram, bars represent the frequency within intervals with adjacent bars. Okay, so earlier I said that the x-axis for the bar graphs are for categories, while y-axis is for the frequency or the count. While here in histogram, x-axis shows the interval or range, while the y-axis shows the frequency or count within each interval. Take note again for bar graphs, it's for categorical data. Histogram is for continuous data. For instance, here we have an example about the customer complaint with the waiting time of the customer at the cash counter of the Jollibee, okay, during the peak hours. So let's see. Okay, here's the data of customer waiting in minutes. And if you're going to create histogram, take note that you should have its interval, the frequency distribution table, and then from that you can create your histogram. Okay, so as you notice, it's continuous. There's no spaces between bars here. Okay, so that's the difference between the histogram and the bar graph. In addition, we have another kinds of graph here. We have the picture graph or the pictogram, the map graph or the cartogram, scatter plot diagram. Okay, so what's with the three uh, graphs here? Pictograph is usually used when you want to present data with pictures or symbols. Okay? It's ideal for simple representations and engaging communication. Usually, for pictograph, it is used for advertisement. It can be seen in commercial, in promotion in social media. Yeah, that's usually used the pictogram. It's showing, for instance, the number of books read by each student in the class using book icons. Then another one is the number of cars sold by different car brands using the car symbols. While the cartogram or the map graph, it's used when you want to distort a map based on statistical data to show spatial patterns and variations. Okay, a cartogram of population density where areas with higher populations are visually enlarged, or a cartogram, for instance, election results, where the size of each state is based on the number of votes. Okay, for instance, as you can see here, we have an example of the pictogram with medical assistance here in the Philippines with its count, with its number when it comes to the PPE, with the surgical mask, with the goggles, thermometers, bottled waters, liquid soap, alcohol, medical protective gloves, and so on. So you can, as you can see, you can summarize the numbers just by looking at this, right? In addition, when it comes to cartogram, it's examples about the class suspensions from the page of Earthshaker. So if you're familiar with the Earthshaker, it summarizes the suspensions here in Metro Manila, especially during rainy season. So as you can see, they can identify if that city suspended the class in all levels from preschool to high school, preschool to elementary, preschool, and no suspension. Okay, and then the last one here is the scatter plot or the diagram. It is graphical device to show the relationship between the two quantitative variables. So usually, scatter plot used when you want to show the relationship between the two independent variables. It's suitable for identifying the correlations, the trends, and the outliers in the data. Okay, so plotting the relationship between the temperature and the ice cream sales. Okay, so if the temperature is increasing, how about the sales of an ice cream? Okay, so as you can see, you can identify. Okay, you can identify the relationship between the temperature and the sales of ice cream. Okay, and also when it comes to the relationship between your number of hours you studied and the exam scores. Okay, you can identify its relationship. Okay, so as you can see here, we have different types or we have different kinds of graph that we can use, okay, to present our data. It depends on our purpose and our audience whenever we have these different kinds of charts or graphs. Okay. Then last one, let's go back to tabular. When it comes to tabular, we use statistics in weighted mean. Okay, we have this main formula, and when it comes to weighted mean, usually we have the survey questionnaires. When it comes to survey questionnaires, from our early discussion, from part 2 discussion, it's used to collect data from a group of people by asking them a series of questions. Okay, they are effective for gathering quantitative and qualitative information. Okay, it's on different topics. Okay, on various topics, opinions, behaviors, and preferences of each person. Okay, so it's usually used for research studies, customers' feedback, employee satisfaction, and opinion polls. Okay, and also take note that we're going to use Likert scale here. Okay, it's used when you want to measure attitudes, opinions, agreement levels, or perceptions quantitatively. Okay, so we have here a PowerPoint Likert scale, and for us to interpret the computed weighted mean, we have here the range. Okay, for instance, we have here the 4-point Likert scale that we're going to follow. So if we have weighted mean of 3.26 up until 4, that is 4 as the scale, and 2.51 to 3.25, that is 3. 1.76 to 2.5, that is 2. Then 1 to 1.75, that's 1. Okay, we have another, the verbal interpretation. So in this case, we use strongly agree, disagree, and strongly agree. Okay, but again, it depends on your study, what is your need in your study. You can modify this. You can change its verbal interpretation. Okay, so take note of this. You can screenshot, you can pause it to copy this kasi later we're going to use this for our example. Okay, we're going to use this weighted mean and also its verbal interpretation. So I have here a sample survey. Okay, so take note that this is just an example. Okay, it's about a gadget investigator store with their employees, with the prices, with the comfortability of customers, and the various selection of their product. But take note, usually when it comes to research, it's divided, okay, per factor. But for just an example, I cover it all. Okay, but in your study, it could be uh, different tables for each factor. Okay, so now let's say for instance we surveyed 100 customers of Gadget Investigator store, and we have this data. Okay, we have the summary of their uh, responses. Okay, so as you can see here, let's say we have employees are accommodating. 42 answered that they are strongly agreed with that statement. 30 agreed with that statement, and 21 disagreed, and 7 strongly disagreed. Okay, so each statement, let's compute its weighted mean. Okay, let's compute its weighted mean. So how to compute the weighted mean? Okay, for instance, we have here employees are accommodating. Okay, so all we need to do is to multiply the frequency to the weight. Okay, all we need to do is to add those products divided by 100, the total. Okay, the total number of respondents here uh, in our example. So we have your weight times the frequency, 4 times 42, plus 3 times 30, plus 2 times 21, plus 1 times 7, divided by 100. Okay, so if we're going to identify its sum, that is 307. So you multiply, then you add all of the product. So 307 divided by 100, that is 3.07. Okay, and the verbal interpretation of that is agree. Okay, it means that most of the respondents agreed that employees are accommodating in Gadget Investigator store. Another example, employees are competent and I can trust their advices. So same procedure, wait times the frequency for 4, 3, 2, and 1 and divide it by 100. So we have 4 times 41, 3 times 31, plus 2 times 20, plus 1 times 8 divided by 100. Okay, so with that, we'll have a total of 305. 305 divided by 100, that is 3.05. Okay, and 3.05 verbal interpretation is agree. So it means that most of the respondents agreed that employees are competent and they can trust their advices. Another one, let's try to compute the weighted mean. So we have 4 times 38 plus 3 times 38 plus 2 times 20 plus 1 times 4 divided by 100. So if we're going to identify its total for the numerator, we have 310. Okay, 310 divided by 100, that is 3.10, 3.1, and agree. So most of the respondents, most of the customers agreed that employees are always ready to assist. Now, you try. Okay, you try the remaining statements, identify its weighted mean, and its verbal interpretation. So you can pause the video so that you can compute for the weighted mean of statement number 4 up until statement number 10, and also identify its verbal interpretation. So again, you can pause the video, then you compute. Okay? I will reveal it later. Okay, so again, you can pause if you are still computing. So it's a long process since it's statement 7 statements remaining. Okay. Now, if you're done computing, you can see if your answer is correct. So we have here the weighted mean and its verbal interpretation. Okay, so as you can see here, we have in prices, most of the respondents strongly agreed that the prices at the store are usually lower than other stores nearby, and the prices at the store are reasonable, with a weighted mean of 3.43 and 3.41 respectively. So remember, if you're going to present your data in textual presentation, you need to present this from highest to lowest. Again, take note, you need to present this from highest to lowest. And also, you will group this based on its verbal interpretation. So you will identify with the strongly agree, with agree, then disagree. Again, from highest to lowest. Okay, then for the statement for the comfortability, shopping at the store, and it's fast and efficient, and there are enough counters to avoid long lines at checkout. Most of the respondents, most of the customers disagreed with that, with a weighted mean of 2.82 and 2.57. Okay? And then you can combine the statement for the various selection of the products with the employees since they have the same verbal interpretation. Okay, so take note, again, you need to present this
if it is in textual form from highest to lowest, and with the category of the verbal interpretation. Okay?